How to calculate thermodynamics coefficient of performance. Have you ever wondered how efficient heating and cooling systems really are? Today, we will break down the coefficient of performance, often referred to as COP, and how to calculate it. This measure helps us understand how well systems like heat pumps, refrigerators, and air conditioners transfer heat compared to the energy they consume. First, let's clarify what COP is. It is the ratio of useful heat transfer to the work input. This means it tells us how much heating or cooling we get for every unit of energy we put in. To calculate COP, you need to know whether your system is for heating or cooling. For heating systems, such as heat pumps, the formula is simple. You take the heat delivered to the hot reservoir and divide it by the work input. For example, if a heat pump delivers for 1,500 watts of heat and uses 1,500 watts of electricity, the calculation would be for 1,500 divided by 1,500. This gives you a COP of 3. Now let's look at cooling systems, like refrigerators or air conditioners. The formula is slightly different. Here, you take the heat removed from the cold reservoir and divide it by the work input. For instance, if a refrigerator removes 6,000 watts of heat while consuming 1,500 watts of electrical power, the COP would be 6,000 divided by 1,500. This results in a COP of 4. It is important to note that COP is a dimensionless ratio. This means it has no units because both the heat transfer and work input are measured in the same units, typically watts or kilowatts. A higher COP indicates a more efficient system, as it provides more heating or cooling per unit of energy consumed. Interestingly, COP values can often exceed 1. This is because these systems move heat rather than convert energy directly into heat. For example, heat pumps can have COPs ranging from 3 to 5, meaning they can transfer 3 to 5 times more heat energy than the electrical energy they consume. When comparing different thermodynamic cycles and devices, COP is a helpful tool. It shows how operating conditions, especially temperature differences between the heat source and sink, can affect performance. Generally, the closer the temperature difference, the higher the COP tends to be. To summarize, the formula for calculating COP is straightforward. For heating systems, it is the useful heat output divided by the work input. For cooling systems, it is the heat removed divided by the work input. Understanding this ratio allows engineers and users to assess and optimize the performance of heat engines, refrigerators, and heat pumps in thermodynamic systems.